right, this is like the first microphone check, so I got to see how close or far away I need to be so you can hear me. Can everyone hear me in the back? Are your eyes amazing, or you're like, do you think we smell? All right, as long as you can see the screen. I think the slides are shared too. But I like the idea of the eyes being amazing. That's great as well. So we're going to talk a little bit about SIEM today. We're going to talk about data. We're going to talk about data lakes, data pipelines, all of the stuff going into your SIEM. And a new way to think about it might be something you're already doing and you're like, that's not new. Might be really new to you. The joy of any single one of these conferences is you learn new ideas, and some of them you take home and test, others you research further, and then some you just forget and say that wasn't for me, right? And those three options are great with any session that you're sitting in, is to determine what it is for you, because you're going to be here for the next 2 days and you're going to learn a lot. And unless it turns into actual actions, then, it was a cool field trip, but did you learn anything? So as we're going through today, try to figure out what are the 1 or 2 things that you should be testing out within your environment that you hear today so that you can take it to your teams and put it into practice. As far as introductions, my name is Joe Cicero. I am a Rochester native, born and raised here, never going to be able to leave, I think, at this point in my life. And I manage our partnerships at Security Risk Advisors. Prior to that, I was at Microsoft. You might have seen my talk last year on career hacking. So if the name's familiar or whatnot, that's me. Mike, you want to go?
Yeah. Hi, everybody. I'm Mike Pinch. I'm a CTO at SRA and I've been a CISO at various organizations around town over the years. So looking forward to talking today. One thing I was just going to say, just real bluntly, is we're going to show you exactly how we are able to achieve oftentimes 6 or in some cases even 7-figure annual savings with some very large clients for data optimization. We will show you the receipts as well. We're not kidding around with it. This can be a very, very important presentation. So,
yeah, we're going to start with some slides, walk through the problem, identify it, fully scope it, and then we will have some demos. Nothing that we do here today is trying to sell you anything. We do talk a little bit about Microsoft. Most of you already own some type of Microsoft in your environment. We're also going to talk a little bit about Cribble. You can pay for Cribble. There's also a Cribble free edition depending on how much you're bringing in. So if you have any concerns about that. But let's jump right into the problem that we face. Everything that we have in this digital estate of your organization, your country, your firm, whoever you are working for, is growing every single day, and you need to figure out what's important and what's not important. And if everything's important, then how are you going to get the budget in order to keep all of that important stuff? And the reality is that many of us are then forced to make hard choices on what we keep and what we don't keep. And sometimes we try to bury our heads in the sand, and sometimes we blow up our budgets. And that is the problem that we all face. Who here has growing storage costs? Costs a lot of money because you have more and more stuff coming into your environment, right? This is a common problem. And who here likes going and asking your finance department for more money for storage, right? Who here would rather go ask for more people, more talent, more investment, not necessarily just paying for more storage? So in order to get there, we need to start to deconstruct what a SIEM actually does. Because I think for the longest time, that has been our answer. And it still is part of our answer, but it's not the whole answer in itself, right? If we look at a lot of security products out there, they have sub-portals that you can go in to find information, right? But it's not inclusive. And ultimately, it needs to be all somewhere so you can write playbooks, so you can build things, so that you can respond, identify all the things that you need to do. So we start to boil down, what does a SIEM actually do? It brings in your data, it stores it, you can search it, and you can start to manipulate it a little bit to try to find things. And for many of us who are analysts, it's opening up that SIEM every day and looking at the tickets and investigating incidents, closing them out, and working all the way through until you try to get rid of at least all the high priorities, and maybe you touch some informationals. And that can be a never-ending burden if you're in any type of those analyst roles. It's a very hard job to have. Now, the SIEM strengths is now you have case management. You can bring it all in, you understand what's going on in your environment, not just what's going on the Microsoft side, but now we know what's going on with your Cisco firewalls, or maybe you have CrowdStrike EDR running. How do we bring that all into one space versus, I go to that portal for that portal for this, over here for that, and that really important cool crap over there that I probably should be having, I don't even know how to connect it, so it just lives over there and hopefully nothing bad happens. But that starts to emerge or show some of the SIEM weaknesses, right? So long-term storage, the cost of it. If you want to put in everything, then you're paying for everything as it goes in. Automation, some limitations there, and then interoperability with non-SIEM systems, and then some hunting that you might not want to do in your SIEM, you might want to do elsewhere. But we are stuck in this legacy model, meaning that we have our data, and we've connected it to our SIEM, and we say mission accomplished. Our job is to make sure that the logs go into Sentinel so that my analyst team can look through and respond appropriately. What we're going to challenge in our presentation today is that there is a middle layer, which is your data layer, that can exist in between your destination source of SIEM and your log producing sources to better route and make sense of all of that information coming in, and ultimately, as Mike already alluded to, save a crap ton of money. So what this means is we have to change the conversation to one about the data versus just calling it the logs. It's not just about the logs, because the logs include lots of data. Lots of it is repetitive, not needed, not actionable, and if you're trying to figure out what you need to parse, a lot of it can just simply be overwhelming. So if we stop looking at it as this log and that log and instead say this is the amount of data, and what in that data do I actually need? What am I going to act upon? What's nice to have versus need to have? So this is what we do differently and what we're going to encourage you to do, or to at least test out within your organizations. We introduce a data lake in between the logs coming in and your destination SIEM. The reason why is we're going to show some tools today that allow you to rationalize your logs, to clean them up, to compress them, and then ultimately to bifurcate where they are stored. Not everything has to go into your SIEM. Some things can go into other storage, and just because you put it in a other storage option does not make it any less searchable. That's one of the misnomers we have to tackle, because sometimes if it's not in the SIEM, then I can't look at it, and therefore it's just cold long-term storage.
One thing I would add to, Joe, here on this slide is sort of the blue, green, and purple there. That's the concept of a data lake, and it's essentially shifting to this data lake-centric design pattern. The key element, Joe touched on it briefly, and there's a lot of misconception about what is a data lake. It is somewhat of a general term. And there are different ways to do sort of data lake, but the key things that Joe kind of pointed on are the key elements that I would emphasize you're going to want in sort of a data lake design pattern is the establishment of hot data. There is ways to store data in various cloud services that would be considered cold, that you have to rehydrate or warm up, or you have to, run a query and come back 10 minutes later, or you have limited querying functionality, you can't join tables, things like that. So what we try to emphasize is finding a solution for a data lake that is allows you to keep all of that data hot and searchable and usable. There are different ways to do it. Joe sort of mentioned earlier our favored is Azure Data Explorer, but there are other ways to do it. But we're able to achieve quite literally a one-tenth cost profile. One-tenth the cost of putting data in the SIEM by putting it into a data lake, and it's fully hot and searchable, and we get a year of history instead of 90 days, which is a huge difference. And so just by the way the data is stored, but we get it, again, it's fully hot, it's searchable, it's usable, you can run reports out of Power BI or Tableau directly out of it, all of those things, and it enables all the other things. So data lake, not all data lakes are equal. You want to look for a data lake that has those sorts of attributes associated with it.
So if we understand the concept loosely, you're going to dig into it a little bit more of this idea of a data lake. We then need to talk about where and what logs, right? If you're a healthcare system, you have Epic Health, right? Many of us who are healthcare consumers, all of us probably have to log into some type of health chart, right? Where do those logs go? How do we route those? You have obviously your endpoints. You have your firewalls. Probably have some stuff coming from your identity solution. All of that is rolling in. And we would call that your security data pipeline, right? Not calling it logs, calling it your data pipeline. What are the things that we actually want in there? This is part of your modern SOC operation, right? This is part of the conversation that you should have with your teams. It's about channeling your data and transforming it, enriching it, and ultimately reducing it so that you can do things with it, right? So there's two parts. Obviously, there's the cost savings, right, which is not so that you can give money back to your finance department, so that you can reinvest that funds in something that probably means something a little bit more to you. But it's also your ability to then do things with the data that you otherwise couldn't have done before because it was just a huge log file that didn't make any sense and you didn't really know what to do with it.
Yeah, I will add here, I think Joe kind of emphasizes here, this is a critical feature of a modern SOC operation. We think this is for medium and large size organizations, rightfully a part or full-time employee type of role could be, and it will pay for itself many times over in doing that. But we attract, put butts in seats with cost savings, but there's all sorts of operational benefits. In addition to having much greater visibility and observability of your log data, but that allows you to do things like better understand your log data, document your log data, and ultimately write better detections off of your log data, as well as sort of enhance hunting and a lot of other things. So there's all sorts of other tangential benefits to this, and we'll show some really cool operational things that we're able to do that most organizations have never been able to realize on their own.
So here's a fun graphic. If we look at our pipeline management, it's going from logging everything to logging what you need. The shift to cloud-based SIEMs has caused a lot of folks to challenge what they store in their SIEM, right? If you have an on-prem SIEM and you don't have to, if storage is not a cost issue for you, then it's fine to load it up. If you're paying for a cloud storage solution or something hosted in the cloud, it's now something that you have to rethink. What logs? Why? Does it make sense? What is the risk of not taking a certain piece? And then obviously not all logs are created equal. Some are going to be, that 1% of the time it's a big thing. Others are 100% of the time they're a big deal.
Joe, before you go off this slide,
yep.
That's actually probably the most critical point here is this bottom bullet. We see sort of two arrows coming out of there, if you can make that out. And this is actually probably the most important and critical key function of a security data pipeline. As you go through and start to ingest all of your logs into a pipeline, you can make informed decisions once you see that data as to whether those logs belong in your SIEM or belong in your data lake. The way we approach things is we send a copy of everything to the data lake. It's because, as I mentioned earlier, the data lake is so inexpensive. Send a full record of everything to the data lake, and we use our data pipeline to sort of curate and distill only those logs that we know contribute to a detection of some kind. So now we're in the data ingestion process. We are backstepping from what detections do we have. So we may have a collection of detections that we either aspire to or we already know that we have wherever our SIEM is. But we can look at those detections and say, all right, well, for these detections to fire, we need event ID 4662 out of Active Directory, or we need Palo Alto wildfire logs, or whatever it might be. But you can essentially start to back up from your detection profile, your threat profile that you're building to detect threat actors with, and just fire in the data that is either directly contributing to those detections in some way. This actually will cut down the amount of log data that you need to ingest in your SIEM, often by like 80%. It's incredible. Yes?
Is there a pre-created list of events that would be recommended to focus on, or it's going to be a case-by-case?
I don't have a pre-created sort of general list for everybody because everybody's log sources are so different. We have some conceptual types that we often work with clients. I know, like, for example, there's some really good on very common systems, especially like Microsoft logs, like event IDs for Windows. There's a ton of stuff on the internet that will help you sort of correlate different detections to that. You can also use things like the MITRE attack framework to build a collection of attacker profiles that you might want to protect your organization from. understand what techniques and tactics they're using, and then apply Sigma rules. Sigma rules, if everybody's familiar, Sigma rules are a collection of, a repository of rules that you can use to write detections. It's a generic language, but those will inform you specifically the log source type that you need, say a domain controller event ID, or a particular type of firewall alert or something like that. So there's a lot of resources out there around that, but it's hard to create sort of a generic master list for everybody. So good question though. Please just raise hands if you want to ask questions.
Or just shout out.
Yeah.
Just no
yell.
obscenities.
Throw something, it's fine. Yeah, him.
Yeah. So let's talk about making sense of the logs. You'll go to lots of presentations at this conference where they'll show you all of these logs that come in. And a lot of it you try to look at and you try to read a log like it's a story, right? What's the information that's there? What's the unique identifier? What are the things that I need to parse? And if you start to read the language of the log, you might see, oh, this is duplicative, or this is just nothing I'm ever going to use. Why is this in here? If your mission is just to connect logs to the SIEM so that you can do your security operations work, then you end up pulling in a lot of this stuff that is repetitive, or you're not going to use it. And the downside there is you are obviously paying for that storage, but also when you go to start to build some of your correlation, some of your investigations, you have some of this stuff kind of polluted in there and you want to clean up your environment. So here's an example of a native Windows event log. Folks in the back can see it perfectly because they swore they had perfect vision. But in this native Windows log on the left side of your screen, or 70 of those screens, there's 75 fields per log. It's about 3.75 kilobytes in size. And if you look at the red areas that are highlighted on the screen, you'll see that they actually repeat themselves. So it's duplicative information. It's the same information over again, just in a different comma separation of how it's organized.
It's important to remember these logs were created for IT administrators first and foremost, right? Not necessarily security folks. So we are consuming things. There's all sorts of information in here that we don't necessarily need to fire detections properly. Great point.
So when we start to clean that up, we can take 75 fields down to 30 fields. We take it from 3.75 or 3 3/4 of a kilobyte down to just over a kilobyte in size. Remove redundancy, and what I think is one of the more important ones is remove the noise so that as you're connecting and creating, you can actually see what's working versus looking at all of the stuff that's listed. And then obviously set up your intelligent routing. As Mike was saying, put everything, in our case, to ADX, and then figure out, in addition to where everything is going, our data lake, what needs to then go into the SIEM. The outcome here is we'll round that up, 69% log size reduction and 90% cost savings.
I want to emphasize too, that's without dropping a single row of logs. We are taking every log, we are just getting rid of the noise in each individual row. And so that's a 68.5% cost reduction right there for typically your most expensive log source. After this, we then make a decision as to whether this log needs to go to the SIEM or not. And so the key thing I also emphasize here, which is sometimes folks ask these as questions, is a good question, is what we're able to do. This is a screenshot out of Cribble that we use as our data pipeline. We're able to ingest that feed once, run it through 2 different pipelines, one of which will route the full data set without eliminating any of these fields to Azure Data Explorer, ADX, as Joe mentioned. The other pipeline applies all of these transformations to it and then puts some of them into Sentinel, the ones that we need. So we're able to distill the logs and then only cherry pick the logs that we need for detections to go to the SIEM. But this allows you to retain a full record of unmodified data, which is oftentimes important for various compliance reasons and things like that, in your data lake. So your data lake becomes the formal system of record. So we're not choosing where to send each log and sending it to one or the other. We're sending everything to the data lake and then only the stuff that matters to the SIEM, the stuff that matters for alerting. And the good thing about that is, in our case, if we use Azure Data Explorer and Sentinel, which is our stack, use the exact same querying language to search those 2 platforms. In fact, you can search one from the other and integrate the 2, which is really cool. But what you're able to do with this is if, a new threat emerges tomorrow and we don't have that event ID in the SIEM, oh no, what are we going to do? Very easy. We start a threat hunt. We write a KQL query in Azure Data Explorer to do a threat hunt for that particular threat historically in our data lake because we have all that data. And we literally turn that KQL query into a detection in the SIEM and make one change in Cribble to reroute a new event ID into the SIEM. So we've got now historical comfort for that new and emerging threat based on a quick threat hunt, and that same threat hunt logic becomes a active detection in the SIEM. Same language, same, just tab one window over, drop it in as a detection, and then reroute your log data. So even when you don't have perfect foresight, you have the ability to go back and see everything you need.
Yeah.
Question. Love that previous slide and just the overall concept articulated. More of a tech question. Why are data lake storage costs so much cheaper than the SIEM?
Different architectures, there are a million different data storage architectures out there that all satisfy different needs. Some of them are incredibly fast to write data to. Some are incredibly fast to read data from. Some are architected for data recency. Some are write once, read many, and you can never overwrite it. Azure Data Explorer, in our case, the one that we use, the reason it is so inexpensive is, number one, it uses Azure Storage Containers, blob storage. So it uses sort of generic, cheapest tier storage, similar to like an S3 bucket. You don't have access to that, but you pay for the usage of it. So you can't actually drop files into a storage bucket necessarily on the back end, but you pay for the data storage that you use. But what Azure Data Explorer does is it uses what's called a columnar database architecture, which as it ingests data, it splits all the data into individual columns. And if you think of a database column, all the database columns have similar types and attributes, which means they can apply compression on those individual columns and get incredible data reduction. So if you send 100 gigs a day into Azure Data Explorer, you can have a year of history, and it's going to cost $10,000 to $15,000 a year for 100 gigs a day stored for a full year. It's 10 times that for most SIEMs. Now, the reason they do that is because when it's actually written to disk, it's like 3 gigs a day. That's the trick. But because of the way the architecture is with a columnar database, you're creating a much smaller haystack to search when you are searching, for that needle in the haystack, because each data set is much smaller. And so it has an ability to decompress data on the fly. And so it's all hot, even though it's compressed and stored. So it ends up being a perfect, it's a database architecture that's been around for a very long time. But this is like its ideal possible use case. Very detailed answer, sorry.
All right, let's keep us going on. This is just another visual of what we're doing. We're not deleting any data. We're just putting it all into
I can summarize this real quickly. Essentially, we have our traditional on the left-hand side, going from left to right, just 2 log sources going in, and that green bar is the amount of volume you're putting into your SIEM. And then when you switch over to sort of a data pipeline routing from right to left, that green bar is now the data lake, and the SIEM is representative of how much data you're putting into the SIEM. So it's shuffling and redirecting data, the vast majority of it. So.
And it ends up looking something like this, right? And you probably have something just as beautiful created for your environment. Everyone have something like this, nice and pretty? Some people do. Some people wish they had that. Probably a good exercise to figure out to draw it up and have that schematic. But here we have the log sources flowing in. In this example, every Microsoft native source, like let's say Defender for Endpoint, Office Identity, those can flow directly into Sentinel, so you get all the benefits of the pre-configured Microsoft settings. You get the perks of the out-of-box features, but there's other things that are not, in this case, Microsoft, third parties, or some firewall logs, et cetera, that need to be connected. And for those, we're going to plug those into a product called Cribble. And as I mentioned before, there is a free version, so it's not selling you anything. Obviously, if you need more, you might need to eventually buy it, but it's not something that should stop you from playing around with it today.
There's also a free instance of Azure Data Explorer, just so you know.
Ooh, I did not know that. I used to work at Microsoft. They never told me the free stuff. So let's look at what this actually looks like, because now we've talked a little bit about architecture. We've said like save money, you can use it better. All of these things are probably giving you that like excitement factor. We want to put some numbers on it. So the first thing we're going to do is look at a Fortune 200 company. It's running the Splunk SIEM. Ingestion is 1.2 million a day. And as a result of putting Cribble in between and going that data lake model, or actually this one doesn't even have the data lake model. This one's just using Cribble to clean up some of the logs. The reduction was about 430 gigabytes a day. And obviously that saves on Splunk spend. And the only two log sources were brought in for this project. It was firewall and your VPN logs. So just two, not everything, just two. And the result was $400,000 a year in savings. So this is not a data lake. This is just using some type of data pipeline tool. In this case, Cribble, in order to clean up and compress the logs so that you're saving money in a good amount. I would like $400,000.
Freeing up room to put in new log sources. I know in this particular case they were bumping up against the rev limiter of their terabytes a day, and so they were able to now send in new log sources as well, which is good.
I think that's a great call out. The reality is you're not going to say, ooh, I saved $400,000 a year. I'm going to go give that back to somebody, right? It's I want to hire the team that I should have. I want to, promote team members. I want to get the right training, et cetera. It's not really savings. It's reallocation towards higher value projects.
Hire a security data pipeline engineer.
Healthcare provider here. So this is, they migrated from Splunk Cloud to Azure Sentinel. In this case, we did Sentinel with that Azure Data Explorer, ADX, with Cribble in between. The Splunk costs were $900,000 a year before. Afterwards, the Cribble plus Azure Sentinel plus ADX costs were $200,000 a year. Again, that's a big amount of savings. It's more important than just the cost savings, though, because you get better detection capabilities, you get better rationalization of the data, and now you have a full backup because you're backing everything up into your ADX environment. So it's very easy to see the cost savings as a pushing factor of this is great, but there's also the added benefits that you get from following such a model. Do you want to walk us through, Mike, the Cribble pipeline?
Oh, sure. So we'll talk a little bit about data pipeline tools. Joe's mentioned Cribble a few times. There are a couple ways to approach this. There are other tools out there and different ways to do this. You can do it with free and open source tools. There's other tools like Databon, Azure Monitor Agent is starting to support multiplexing to multiple destinations as well. So the concepts that we'll talk about here should hopefully apply. But just looking a little bit at sort of overall, one of the niceties that you get out of having a data pipeline, whatever that might be, is a centralized place to observe and see the relative and overall health of your log shipping environment. If you are shipping dozens or hundreds of log sources, having them all being shipped directly into a SIEM or through some sort of complex network or family of syslog systems or logstash relays or Windows event forwarders, Windows event collectors. Those things, if anybody's ever had to deal with that, it's a headache every single day. And by using a data pipeline tool, you are able to consolidate all of that, typically through one logical user interface, which is what I'm showing here. The niceties that we're showing in this particular screen is, immediately be able to see the relative health and wellness of all the CPUs that are running across your data collectors, memory usage, storage usage, your ingestion versus your output feeds, things like that. I'm going to show you some other cool things that you can do with it as well after that. So one of the things that you can do also is individual log ingestion feed health and wellness, managing and measuring inputs, outputs, throughput, all that sort of stuff. And these are good metrics, but one of the things that we've done is we've actually used Cribble as a log source as well. So if you think about your SIEM as an alerting engine, we can have Cribble actually trickle all of this data into the SIEM, and we can start to write rules and detections to say, hey, are we seeing an abnormal volume of logs? Escalate that, or is your log data did a log source fall off? And I'm going to show you a couple examples of that in just a minute. The next thing I was going to talk about here is a pipeline. So we've mentioned pipelines a little bit, but the way this works is once you ingest data, whether it be through, Cribble can emulate a Windows Event Collector, so you can get rid of your Windows Event Collector infrastructure and just turn on Windows Event Forwarding if you want. It can do syslog, it can call REST APIs, it can connect to just about anything imaginable. I've yet to meet something we can't necessarily ingest, but once it's brought in, it goes into what's called a pipeline. This is where you do your work on the data to start do those modifications. If you think of that screen earlier that Joe had, that was that red and green, lines crossing out different data fields, that's done through here. And so you can apply step after step on certain portions of the data of transformations, and this is all done and executed in real time. And you do this in one sort of centralized console, and then you can push that logic out to what they call workers that are essentially headless units that will ingest that data and apply your logic on those feeds. But in this case, we're showing some ways that we can use to drop data. We can run regex on data. We can match it. You can even enrich data. There's a lot of good techniques to sort of bring in other data sets. Say you have user accounts that have totally obtuse naming conventions, like a letter and a bunch of numbers, and you want to maybe keep a table of a crosswalk table and actually augment the log and add something into the log to say this user ID is actually this user's name, or here's their email address. You can do that. So you can enrich your data with this just as much as you can reduce your data. So all of this is done within a pipeline. And so we'll create, for one source, 2 pipelines. One is just going sort of straight through into our data lake, and one is going through this sort of culling process and then deciding which actual rows we want to drop or keep based on our detection fabric that we're trying to create. This is a good example that I wanted to kind of emphasize. I really like this one. This is, to me, really puts together the big picture of why we do this and how to approach this, to my comments earlier about threat detections. So if you're familiar with doing a DC sync attack or trying to defend against a DC sync attack, writing a detection for a domain controller sync, DC sync attack, requires Windows Event ID 4662, okay? So Windows Event ID 4662 is incredibly noisy. It is extremely noisy. Many organizations don't even ingest them or turn them on because it costs so much money to ingest those logs. Well, it turns out in order to do a DC sync detection, you need Windows Event ID 4662, but only with a particular object GUID, which is just a big, long global identifier that is apparently just a Microsoft standard name for a particular type of Event ID 4662. You only need those logs, and those are like less than 1% of the overall volume of logs. And so we noticed when we turned on Event ID 4662 for a client that their costs went up overall into the SIEM. And so what we were able to do with our data pipeline is filter out and drop everything that was Event ID 4662 that didn't have this particular object GUID. And we can see it on screen there. This legitimately overnight produced an annual $55,000 a year savings just from reducing their Sentinel costs by optimizing it and stop putting data in that you don't need. So this to me is kind of, whether it's, us as a consulting firm or anybody running their own program, this is the kind of regular cadence of analysis that we're doing on the data with the visibility that we get through this tooling. And now we have this power and availability. This helps us be better at writing detections as well. Like I learned something about DC sync attacks I didn't know because we, dive into this. And just having somebody sort of going through maybe it's your tier 3 engineers and your SOC type folks, and continually understanding where your costs coming from, what is producing value, what's not producing value, is an incredibly valuable exercise. So I talked a little bit about data lakes earlier, and SIEM. This is just a screenshot from Azure Sentinel, which is the SIEM that we often use. One of the things that one of the reasons we like the stack that we use with Azure Sentinel and Azure Data Explorer, as I mentioned earlier, is you can actually query one from the other. And so you can have what they call workbooks in Azure Sentinel that have KQL queries that actually reach out to the data lake and pull data in real time. It's not writing data to a new table. It's literally just getting it in real time, and you can actually write queries in KQL that will join a table from your data lake with a table from your SIEM and produce results and visualizations wherever you want in overall Azure. And so it's a really nice design pattern and not one I've seen from other vendors to really stitch together that data lake layer and the SIEM layer. So that was one of the core reasons that we kind of chose that as a platform. This is a screenshot of Azure Data Explorer. Actually, no, this is not a screenshot of Azure Data Explorer. This is a workbook in Azure Data, or running in Sentinel, showing us data out of Azure Data Explorer, as I was kind of describing earlier. One of the things that I really like about the platform, at least, is that it lets you do really powerful data visualizations. It has all of those tools built in. In this case, we're just doing graphs and charts, looking at table volume and table usage. I'm going to show you some live stuff on that in just a minute. I mentioned earlier, KQL is the query language. It stands for Cousteau Query Language. There's other KQLs out there, but Cousteau Query Language is sort of an evolution of SQL. Microsoft, I believe, created that language. It's extremely well written, has very, very deep analytical capabilities. You can do a lot of stuff that you can't do in other SIEMs very easily. Similar to Splunk. Splunk has very good analytical capabilities as well, but being able to do things like standard deviations to find outliers over periods of times and things like that, you have a lot of very, very detailed analytical capabilities in it that you can use, and you can port that back and forth from your SIEM to your data lake. And so we'll do threat hunts in the data lake, and now because we can go back and use a year history in the data lake, we do our threat hunts there. We can port those threat hunts to now become real-time detections in the SIEM if we want to move those over, because it all uses the same language. Your detection, your hunts, everything now becomes the same language, which is nice.
Hey, Mike, so we're talking about ADX, we're talking about Cribble, we're talking about Sentinel, and we're talking about doing some hunting inside of ADX. What does it look like if a customer does like Copilot for security, right? That's one of the new Microsoft products out there. Does that break anything that they would be able to do in Copilot for security, or is that a concern they should be thinking about, or not really?
No, actually. So the nice thing is with Copilot for security, it is oriented around your sort of Microsoft properties. However, there are a number of very easy ways to build plugins. In fact, maybe you asked that because I wrote a blog post about this, which is good. It's fine. Where you can actually extend Copilot's visibility into other tools. And so it was probably 30 lines of less code and more definition. Essentially, I embedded a KQL query inside of a definition file to create a plugin for Copilot that will tell Copilot, hey, if you need NetFlow logs, go execute this query in Azure Data Explorer, and Copilot can go and do that. And so we can actually expand Copilot's visibility in a matter of minutes to work with data lake data and other things. So that's, again, one of the nice features of this. One of the things I wanted to show here, which is going to be, see how this goes. Just a little bit of live stuff here. I mentioned sort of with a data pipeline and data lake, we use Cribble as a data source into that infrastructure. And we're able to, this is an Azure Monitor workbook, but what we're able to do here is build a baseline of what's normal for every single log source for every single client that we run and operate around the world. And be able to, as some of you might know, a Palo Alto firewall log and your privileged access management produce very different volumes of logs. So creating a single rule that says, hey, if we haven't seen a log in 5 minutes, fire an alarm, doesn't work if you get 10 PAM logs a day, right? And so we were able to feed all of this data into our data lake and produce, as my engineer calls this, the exponential distribution variable rate and intelligent thresholds chart, which will look at each individual log source and give us a red, yellow, green on its overall health based on the statistical probability that it is having a log source outage of some kind at this particular moment in time based on its historical lookup of what's normal. And so every single log source gets its own sort of algorithm generated for its overall health. We're able to use this to actually trigger tickets in our Azure DevOps system for our 24/7 managers to say, this log source is down. Go work on it. And even better, as we all probably know, when log sources just magically turn back on and start working again when we didn't do anything, it will actually recognize that and go and close the ticket for it, which is really cool. So I just have another tab on this workbook here that I was showing that just shows, a collection of particular alerts. We have one Sev3 open now, one of these is fixed. But this allows us to get this visibility into a very complex set of log sources all through that single pane of glass. The other thing I was going to mention that we also have here as additional tabs in here, with Cribble, we set up worker nodes. Those are the things that actually do the data processing. They call home to that nice user interface and get their instructions. But we're able to monitor a global distribution of every single computer, its CPU usage, memory samples over time, and build the same sort of overall health volume or health monitor to make sure that everything that is processing our logs is healthy. And then even more so, when the log data is going into, in this case, Azure Data Explorer, we're able to monitor the Azure Data Explorer cluster's health and wellness. Azure Data Explorer is a SaaS solution, but it does expose sort of what volume of CPU and memory and things like that you're associating with it. And so we're able to get very detailed usage of CPU volume over time. Really important is ingestion latency. So we're able to measure ingestion latency. So if you're pushing data in, if you have big spikes, you might see that your ingestion latency might go up to 10 or 15 minutes, and we can auto scale now the cluster of Azure Data Explorer to deploy new nodes to help speed up that during time. So makes for a very advanced set of capabilities there.
I think this is so important because now it's your smoke detector for the smoke detector.
Yeah,
right? If
exactly.
something stops working, how do you otherwise know?
The guard that guards your guards.
The guard that guards your guards.
Right.
It's a great T-shirt.
So I guess a couple other things, just talking about the SIEM component of it. This is sort of the really simple architecture. The key thing I like to point out there is that little line between the data lake and the SIEM, which is, to me, is the key thing to establish there for interoperability. And then kind of how we bring data in with Cribble architecture-wise typically looks like this. You can run it on-premise or in the cloud. You can have Cribble host your leader node, as they call it, which is where you do all your development of your data processing, and all of your worker nodes are headless infrastructure. So what we do is we actually spin up these Cribble worker nodes in what are called Azure scale sets, which are automatically load balancing. So they come with a load balancer and multiple worker nodes behind it that are all running the same logical routines, and it will spin up a new worker node anytime it needs to scale up and scale that back down when it doesn't need it. So auto scaling there, and they can be essentially headless. So we're able to treat it like using modern DevOps properties, cattle, not pets. So if we need to patch something, we just build a new image that's patched and we drop it into the worker pool, and it will automatically cycle that in, and we have zero downtime patching. Even if we need, essentially we just kill the old images and spin up a new one, wait till each Cribble worker has drained, and then it will drop all of its, kill that one and spin up a new one. So works extremely well, extremely high resiliency with that as well. Last thing I wanted to show here, I guess, was a quick cost savings demo, which let me hit escape, see if this works. This is one that I kind of teased at the beginning here. But one of the things that we're also able to do, because we're able to track exactly the volume of data that we're getting in and the data that we're putting into Sentinel, so we can see all of this data out of Cribble, we built workbooks in Azure Sentinel that actually show you how much money you're saving. And so it might be a little bit hard to see here. We'll see if I can zoom in a little bit. This is per table, per month savings that we're doing for one of our clients. This is a Palo Alto log source. We've got GCP, Blue Coat. I've got a dozen more down below here, but I'm just going to focus on these top few. That says $188,255 a month of savings that we're seeing by deflecting and minimizing the size of logs that we're sending to Sentinel. So we are still getting threat logs, wildfire logs, VPN logs, things like that into the SIEM, the things that we need. We take an aggressive approach with firewall allows and denies. We divert firewall allows and denies to the data lake. We will use SOAR automation to do things like threat sweeps and things like that across those firewall logs that are in the data lake. So we'll run a SOAR routine every 15 minutes to go and grab all of the recent firewall logs and apply threat intel and do a threat sweep and have it open an incident in the SIEM if we need to. But we don't need to send all of those firewall allows and denies into the data lake or into the SIEM. If we want to do some sort of detailed analytical work on them, we can set that up on a schedule through a SOAR automation using something like Logic Apps. But it's not just that. We've got GCP logs right below that. That's $138,000 a month of savings. Below that, Blue Coat, $21,000 a month of savings. And so this is something that can be extremely valuable, obviously, freeing up the ability to do what you want with your funds and really enable other aspects of your security program.
And the cost savings isn't from deleting data, right? Because the full copy is still in ADX.
We didn't lose any data. We have all of that data, and we have it for a year instead of 90 days.
So we're not deleting our way to savings. You're just optimizing, and then Cribble does some compression on top of that. And because of that ADX plus Sentinel model, that's how you're able to cut down those costs.
Yes. So we're just about on time. We have a few minutes. Any questions or yes?
So my architect's recently been teaching me about open telemetry. Is this essentially open telemetry under the hood, or is there extra value added because it's a SIEM-based agent?
I'm not fully familiar with open telemetry to answer that question. I don't know offhand. I don't know if anybody else knows in the room and wants to answer it. But I've heard of it, but I haven't actually double-clicked on it enough to read it, to speak intelligently on that.
Grafana Labs has Grafana Alloy, which is a collector, and then it provides the transformer with it, so you can collect the logs and then transform them and strip out the stuff you don't want.
That sounds to me to be like a open source or a competitor to it. So it's definitely, I would say it's certainly not based on the tools that we talked about, but probably absolutely trying to do exactly the same thing. There's a couple others. There's Apache has a project. I forget the name of the Apache project. It'll come to me after the presentation. But there's a couple of other projects out there like that. Yeah. So I would imagine that's very very much sort of the same concept.
Well, so what I'm wondering is what is the extra value with the SIEM-based one? Are there different logs or different areas of the system that get collected that one of the open source tools would not be grabbing?
So I guess is your point open telemetry is not really a security oriented, it's more just a general log? Yeah, that's actually what Cribble is as well. We just kind of stole it for security or use it for security. And so I would have to look at sort of what tools it supports and everything like that. I have looked in certain cases for other log collectors to do certain things and open source, some of the syslog ng and other things like that, and had trouble finding the ability to get all different types of log sources. So I know, at least with Cribble, there's somebody you can pay to, make whatever log source you want. So Windows Event Collection is a big one that'll emulate a Windows Event Collector. I don't know anybody else that'll do that. So yeah, I think you will probably get more broad source and destination support. That's probably one of the bigger differences. Yeah.
Sentinel, you have all the ticketing meta in the project. If you deploy it correctly, you have the SIEM, you have ticketing, you have support, follow-up, and self-resolving tickets and all that. So
Yeah.
the added value of Sentinel.
Yeah, absolutely. That's personally the thing I like the most about Sentinel is it's, frankly, it's kind of a Frankenstein SIEM. It uses log analytics. It has the Sentinel layer on top of it, but you have the power of the entire Azure ecosystem when you're in there to do whatever you want. We have we have built crazy functions using Python that are running in Azure functions. We've got SOAR automations. We're using event hubs. We've got, using Logic Apps to bring in vulnerability data to enrich the data sets. There's a million things that you can do with it that works really well. But one of the things, to your point, is we use Azure DevOps to manage all this. So the other cool thing, I'm really glad we did this when we started doing this 4 years ago, is we built everything out as infrastructure as code. So all of our work is actually represented as code in Azure DevOps. And so we can essentially hit a button and deploy, and we're now building detections, and all the content that goes into the SIEM sort of at the data plane layer is also going into Git first, and then it goes out everywhere. And so you can do that. And then, as I mentioned, like a data outage can result in an Azure DevOps ticket being opened and routed.
So I see we're close on time.
We got more questions.
Oh,
Yeah.
okay. For your question, I'm going to do a little commercial break. This evening at 5 o'clock, we are hosting a happy hour with free drinks at Heroes Brewing. It starts at 5 o'clock. It's right on Atlantic Ave. I have cards if you're interested. What's cool about Heroes Brewing is for every beer you drink, money gets donated back to the charity that worked to make that beer.
You're drinking for good. Yes.
Oh, I just wanted to add some flavor to your question. So these agents or collectors, right, depending on whether it's Turtle or Datadog or, I can't remember well into my previous life. The agent is usually a proprietary agent, but some companies will support OTel agents. Like, if you want to build it from the ground up. So under the hood, you may or may not be OTel.
And I caught the word agent as well in there, and I don't think we mentioned this. We don't actually use any agents in the way we do any of this. So like our designs are typically agentless. Doesn't have to be. I guess Cribble has an agent. They have something called Cribble Edge. But we find that the collector infrastructure that we put up in load balanced stuff in the cloud has so many adapters for sources that we don't need to drop agents anywhere. So if we want data from endpoints, it's either coming from EDR or it's coming from Windows Event Forwarding. And if we want, firewall logs, it's coming over syslog connector, and we can do Leaf, we can do Ceph, we can do whatever. And if it's coming from some random thing out in the cloud, we can call a REST API. So we find that there's not a lot of need for agents anymore, to be honest. So, other questions?
All right, now that you just fired your agent.
One more.
So, today's topic is about optimizing for costs. And you mentioned Copilot for Security, which would, of course, be an additional cost. Full transparency, I'm with Microsoft, but I'm so curious. The way that I talk about Copilot for Security with my small to medium corporate businesses is that it's going to save them time with incident summaries, threat investigations, like for email through prompt books can reduce the time quite a bit. So we think about saving our accounts time. And you mentioned it, and so I gotta ask, as a SOC provider, as a managed service provider, does Copilot for Security have a benefit to you as you're managing your accounts security environments as well?
I would say that we are still trying to figure that out a little bit. It does do some really cool stuff. The question was, does Security Copilot help sort of in an MSSP role, I guess, right?
I will, sorry, I'm
go
going to
ahead.
interrupt here and add, though we might not see like direct benefit, it's obviously helpful to tier 2 or tier 3 that can go through and get a little bit more of that investigative work. I don't think it's helpful for tier 1 because some of the prompts that they put into Copilot are just going to eat some of their Copilot credits a little bit too quickly for them to see real value. Another thing that's included with Copilot for Security, again, not with Microsoft, but or I'm not with Microsoft, but it includes the advanced threat intelligence is included with it, which is super beneficial to us as a security partner.
Yeah, I think there's potential on that, and it's an interesting position to be in as like sort of a farmed out tier 1, tier 2 SOC. And Copilot is in some ways almost the competitor in a way, or a challenge to how we operate. And so we have it and we use it in our development environments and things like that, and are trying to figure out the right sort of role for it, and like whether it's our customer that buys it or whether we're going to buy it and provide it and all of those sorts of things. So we're still evaluating that, but we are making pretty heavy use of a lot of the Azure OpenAI type stuff already in there. So there's definitely pragmatic use cases today for it. So good question.
All right, everybody. We're
We'll
a
see
couple
you at
minutes
the
over.
happy hour at Heroes at 5. Thanks, everybody.
Thanks, everybody.